Hello everybody, this is Professor Shagato Chatterjee from Vijisom IIT Kharagpur taking the marketing analytics course for you. This is week 2 and session 3 is something that we will start with. In session 1 and 2 we talked about what customers want. In session 1 we have shown that from customer review data you can find out the preferences of the customers, and in session 2 we have started with briefing about conjoint analysis. That is another quantitative technique which you can use to find out what are the various preferences of the customers, and you can also get data about the preferences about various attributes and the attribute levels. So, you can find out if somebody is trying to buy a let us say a laptop, then how much is the preference for 2 GB RAM or 4 GB RAM or 8 GB RAM, how 4 GB RAM and 8 GB RAM are different from each other. Exactly attribute level preference you can probably try to find out. So, in this session we will actually in a hands on kind of way we will try to see that how I can find out all of these things. So, the first thing is, let us say you are trying to buy a car. In this particular case we are trying to think that we are trying to buy a car, and then you probably go and ask some people that what are the major features, major factors, aspects that they think is important when they are trying to buy a car. And I find out that this is the, let us say, the 3 things that people think is important. One is fuel, one is capacity, means seating capacity, and the third one is the price. So, these are the 3 things, let us say, that comes up to be important, and I also find out that there are 3 labels in this. So, I told that all of these things has to be mutually exclusive, like fuel and capacity should not be compared with each other, and again capacity and price should not be compared with each other. Now, sometimes you can say that okay, capacity and price might be related, and capacity goes up, price goes up. That can be a problem. So, if that is the case, then probably price will not be a good variable that you should take. On the other hand, if you think that okay, even the diesel, the fuel type will change the engine type, and engine type has different costs that will contribute towards the price, then that will also have an impact. So, it is better if you have taken something else instead of price. So, whatever be the case, in this particular case probably I have taken price. And these are the 3 levels. My levels are very, I would say, objective, concrete in nature. It's nothing is there where you can actually say that okay, there is some ambiguity. It's not there. Diesel, you know what is a diesel engine, you know what is a petrol engine, or you know what is a CNG, and then we all know 8 seater means it's a little bit bigger, 6 seater means it's a more of a I would say probably Innova kind of a car, and 4 seater might be something like a Maruti Desire kind of a car. So, we all know, we have seen all of these things, and this kind of price ranges and capacity ranges and fuels are pretty common to us. Now, there are 3 factors and each factor has 3 levels. So, that will lead to 3 into 3 into 3, that means around 27, exactly 27 combinations can be created out of these things. So, what I do after knowing that is I go and ask the customers how they prefer this thing. So, in your data set there will be a conjoint data.excel file, conjoint data price.excel file, and if you go to the first one, you will see in this file, I will just make it a little bit bigger. You will see in this particular file there is serial number and then fuel, capacity, price and rating. These are the 3 things. So, this is a rating based conjoint analysis. So, where we have given, so for example, for the first person we have given 9 choices, out of those 27 we have chosen 9, and we have chosen in such a way this 9, when you are choosing, you are not giving the full design, full factorial design. So, when you are giving the full factorial design, you will give 27 combinations to this guy. But when you give 27 combinations to one person, it becomes very difficult for that person to rate. So, that and to differentiate one with the other. So, he sometimes gives gibberish, or he follow his own heuristic rather than a properly thought out rating. So, that might actually impact in the quality of the data that you are collecting. So, instead of that, we sometimes give a subset of the overall design overall, and that subset will have a orthogonal design. Orthogonal design means that if I give these 9 choices and if I run this for this table, the table that I have selected, if I run a correlation for each column, it should be very close to 0, like the fuel and the capacity should not be correlated, fuel and price should not be correlated, and capacity and price should not be correlated. So, this kind of a design is called orthogonal design, and this is something that we are giving. So, there are various ways to create orthogonal design out of the whole full factorial design. That means, full factorial design means all the 27 choices. So, all possible choices, and orthogonal design is a subset of that, where the correlation between one variable to other variable will be close to 0 or absolutely 0. So, that kind of design is called orthogonal design. It is very there are softwares that we can use, and in a different session probably or different video or different link I will show you how to create this orthogonal design out of a full factorial design. But let us say I have created such kind of a design which is a subset of the whole part, and I have given this 9 choices to 1, and this one guy, the person number 1, serial number means here the person number, the person number 1 has given rating for these 9 options. These are the ratings in a 1 to 10 point scale. Let us say 10 means most preferred and 1 means least preferred. He can also give ranking. Let us say instead of rating, if you have given ranking, and 1 to 9 means 1 is most preferred, 1 rank, and 9 is least preferred rank. Now, if we use ranking, then the only difference from rating and ranking is in the analysis part is you have to change the ranking to reverse ranking. That means, if you have to change the 9 to 1 and 1 to 9. So, anything who gets a 1 ranking should get highest rating, and anything who gets the 9 ranking, that means lowest ranking, should get the lowest rating, that means 1, 9 ranking should lead to 1. So, I will reverse it. So, all I have to do is 10 minus the rank whatever you have given. So, 10 minus 1 will give me 9 rating, 10 minus 9 will give me 1 rating, and so on. So, if we by chance instead of rating I had ranking, I will just change it to a reverse code. That is the only thing that you have to do. Why rating and ranking? Sometimes it is, sometimes customers know that okay, I prefer A over B, but I do not know how much. So, when I do not know how much, then if you ask me to rate, that becomes difficult sometimes. On the other hand, rating, if the options are more or less popular, they know, they have used it before, and etc. If there is much familiarity of the customer with the product category and etc., then I think rating is a better option to go ahead with. So, you ask each of the consumer that okay, if I give you a car which has fuel capacity, fuel as 1, that means fuel as 1 means like fuel as 1 means it is diesel, and then capacity is 1, that means it is also 8-seater, and price of 12 lakhs. So, if this kind of a car option if I give you, how much will you rate that car, or will you actually will be interested to buy that car, and etc. So, this kind of a data has been given. Now, only thing that I have to do is I have to find out how rating is getting affected by these 3 guys. Now, here you see in the fuel 1, 2, 3, these are actually categories, these are not numbers. So, if I do a regression, I have to use these 3 variables as categorical variable, and I have to create dummy variables for them. So, I have to create for a fuel 1 dummy, fuel 2 dummy, probably I can keep fuel 3 dummy as the reference point, and then again capacity 1 dummy, capacity 2 dummy, capacity 3 becomes a reference point, and then I can also create price 1 dummy, price 2 dummy, and price 3 becomes the reference point. So, any of these 3 things I can do. So, I will quickly do that in R. I have given you a week 2 s34.r file. So, that file if you can open that file will, and there is a CSV file also has been given. That CSV file is nothing but the data part of this particular thing. So, if you just set your working directory, put all the files that are there for this particular session in the same folder, and then you set working directory to source file location, and then you read this data. The data is nothing but 540 observations of whatever I have shown right now. So, these 540 observations are actually data collected about 9 observations, 9 options for 60 respondents. So, each respondent is giving 9 options. There are 60 respondents, which creates 540 observations. Now, this is also one of the strength of conjoint analysis, which can create lots of data from small number of samples. So, 9 is okay. Somebody probably can even compare up to 12 or 13 or 15, something like that. It's okay, still okay. So, let us say 16 options you are giving, and there are, let us say 60 people. So, 960 observations you are creating out of 60 people. You are getting 960 rows, and it is good enough to run a regression where you have 3-4 variables, or probably let us say 8 factors, 8 categories in total. So, that is a very big advantage of conjoint analysis, where you can create lot of data from a smaller sample. So, I check the structure of this data, and the structure of the data says that obviously it is reading from a CSV file. CSV file does not know whether fuel, capacity and price are, whether they are categorical variables or not. They are all, in this case, they are all integer variables. So, I first change them to categorical variable, factor variable in this particular case, and then I just run a regression, as simple as that, simple linear regression. So, what I do? In the line number 4, I have written for I varies from 2 to 4. Why 2 to 4? Because fuel, capacity, price, these are the 3 things that I will change. They are from second column to fourth column. Second column to fourth column, what will it do? Data comma I, that means data is the name of the data set. In this data set, the ith column will be changed. How? Whatever ith column was, change it to its factor form and save it back. So, change the data's ith column to its factor form, and then save it back to data's ith column, and do the same operation for I is equal to 2, I is equal to 3, I is equal to 4. So, we just run a loop here, for loops, as simple as that. So, I run that, and then I again check structure of data, and now I see that these guys have been changed to factor variable with levels as 1, 2 and 3. These are my 3 levels. So, 1, 2 and 3, and 1 is level number 1, 2 is level number 2 and 3 is level number 3. So, I am more or less okay. So, now only thing that I have left is I run a regression. So, I run a regression where rating is my y variable, and fuel, capacity and price, all these 3 things are factor variables. This becomes my x variable. So, I just run a simple linear regression. So, you can probably run some other kind of regression, probably ordinal logit regression or something like that, but for simplicity purpose, simple linear regression works. So, see, in this particular marketing research or analytics, there is always you can bring in complexity, but the difference between being a very hardcore data scientist and being a I would say business oriented analytics guy is, the difference between these two is that there is always a dilemma, there is always a tug of war between how much complexity I will bring in this thing and how much of that will be useful. So, if I am running these codes and etc., because it is difficult, once you learn a few lines of coding, it becomes very easy to run things which are repetitive. Otherwise, let us say if I try to do the same thing in Excel For 3 columns I had to create 6 dummy variables one by one. So, I have to write if else for 6 times and then I have to run a regression, put all the x variables in one place, y variable in one place and etc. So, there were lots of problems, and if the data size were bigger, then there was also a problem. So, that is why we are using R, because R, yes, it is tough to learn initially, but once you learn probably a few bits of R, you do not have to become a data scientist to learn marketing analytics. You can learn few lines of coding. So, you see all the thing that I am doing in this case is 12 lines of code, and in there also comments are there, probably 4-5 lines of code. So, 4 or 5 lines of code is actually what you all need, and they are repetitive codes. This is the same code, I will copy and paste it and do something else as well. So, that is why I suggest that you try to do it in R by small coding, and then you try to interpret it in Excel or in some other place, etc. So, here what I am doing is fuel, capacity, price are my 3 x variables and rating is my y variable. I run a simple linear regression. I am not doing much complex model because the return of those complexity is not much higher. Whatever this simple linear regression can give, I will not get very extra, I would say very much different information by doing a little bit more sophisticated econometric technique. So, that is why I am leaving it here. So, if I run this regression, I get certain result, and this is the same result I just copied and pasted it here, so that we can discuss. So, in this is the PPT. So, if you see that our F statistic is actually 5055, which is pretty high. The p value corresponding to F statistic is lower than 0.05. So, we are happy with this regression. Our adjusted R square is very high, 0.9982, that is also something that makes us happy, and then this is the regression that I get. Now, this is probably a data set that has been created, but in real life situation this much high adjusted R square might not be the something that we will get, but as long as you are getting good enough, probably more than 0.3, 0.4 adjusted R square in terms of marketing, it is good enough. So, this is subjective, there are lots of research papers or lots of works in marketing is done where the adjusted R square is further lower, but that is okay. As long as it is a subjective decision, you can, somebody takes 0.2 as the cutoff, somebody takes 0.7 as the cutoff, and so you can take as per your wish, but lower than 0.2 is probably not something is good. Now, if I try to interpret these things, all my variables are coming significant, that is one thing. So, all of them are coming significant, and then the next thing that I have to check is that here for each of the categorical variable, fuel, capacity or price, fuel 1 has been taken as the reference, capacity 1 has been taken as the reference, and price 1 has been taken as the reference. So, if fuel 1 is diesel, if you remember diesel, petrol and CNG. So, diesel, in comparison to diesel, petrol is preferred less, minus 0.266, but the least preferred one is CNG, which is minus 4.33. There can be n number of reasons for that. I am not going into these details why, but there are reasons for that. Then the most preferred is 12 capacity, I think not, sorry, 8 capacity, and then capacity 2 means 6 seaters, 6 capacity is little bit less preferred, minus 2.4, and capacity 3, 4 seater is further less preferred, keeping everything else constant, minus 4.6. So, it is not that a 4 seater is less preferred, but if I keep the price and the fuel as constant, let us say for the same price 8 lakh rupees, will you prefer a 4 seater or 8 seater, depends on what kind of car you want to have, but here in overall level we try to find out that okay, capacity, higher capacity is preferred, as simple as that, and then higher price is not preferred. So, you will see that price 1 was, if I am not wrong, 12 lakhs, price 2 was 8 lakhs, price 3 was 6 lakhs or something like that. Okay, 12, 8 and 4. So, 12 is least preferred 12 to 8 the preference increases by 2.6, and that to another price 3 which is 4 lakhs preference increases by 3.4. So, that is something that we are getting here. Now, I have just copied and pasted it here, the same thing other than the I would say the intercept, I have pasted the rest of the things. Now, I have to find out, there are many things that I can find out from this particular observation. So, one regression analysis, and I can find out lots of stuff from this thing, and we will slowly do one by one to find out what are the various things that I can deal with it. The first thing that I want to know is which of these 3 attributes are important. Remember, we told that we can ask the customer that, okay, do you think fuel is important or capacity is important or price is important? In a 1 to 7 point scale, 1 means no important, 7 means very high important. They will give some rating, and when they give some rating, that it comes 5.8, 6.2, 5.9. I do not know which one is something which is bigger, which one is lower or something like that. So, this is something is more, I would say, from their preference, inherent preference, it will come up. For example, you will see that if you do something wrong in fuel, the change of preference is 4.3. So, 0 to 0 is the upper limit, minus 4.3 is the lower limit. Some people actually try to change all of these beta coefficients in such a way such that each attribute are of similar level. So, they say that change it in such a way that each attribute, this is beta coefficient, the alpha coefficient will be such a way that each attribute coefficients, alpha coefficients, if you add them up, it should be 0. For example, I change it in such a way such that if I add these 3 guys up, it is 0, but the distance between 0 to this is still there, distance between minus 2.66 to minus 4.3 is still there, and so on. So, how to do that? It is easy. You find out the average of these 3 guys and subtract it from each of the observations. So, C7 minus average of C7 to C9, and that is the same thing that I am doing it for C8 also and C9 also. So, this is the alpha coefficients which gives me that if I put all these 3 categories in the same level, if they are, if all these three variables in the same level, if they are equally important, then how one factor can be compared with another factor, another level. So, that is something that is the first job, and if you can plot it, this will give you part votes, but that is not something that we are right now focused on. I am more focused on in the importance of each of the variables. So, what is the importance? The importance is the difference between, it is a function of the difference between the lowest coefficient and the highest coefficient under one categorical variable. So, let us say one categorical variable is fuel, the lowest coefficient is 0 or minus 4.33 and the highest coefficient is 0. What is the difference? 4.33. So, that comes up here. Similarly, here the lowest coefficient is 0 or sorry minus 4.6, the highest is 0. What is the difference? 4.6. Here it is 0, 3.4. What is the difference? 3.4. So, anything you do wrong in price and anything you do wrong in capacity, capacity will change the preference up to 4.6. Here the change of preference can be up to 3.4. That is the unit, the maximum change that can happen. Now, this importance scores is nothing but the individual values by the summation of the 3 values. So, this is nothing but E7 by summation of E7 to E15. What is E15? Just 1 minute. It should be E15 exactly. So, these three values I find out 0.35, 0.37, 0.28 gives me an idea that capacity is something that is more important. The next important variable is fuel and the third important variable is price. So, I get a preference, and these preferences are not coming from the customer's mind or whatever they are saying, probably it is coming from the customer's mind. We are getting the inherent preference that they do not know, they give some preferences, and from that I can find out that these are the 3 important scores. They are not verbally saying, because oftentimes what you verbally say is not how you behave. So, I am trying to get this data from the behavior. So, that is number 1. So, this is something that I have reported here also. Now, I will show you there are lots of different stuff that we can do using this conjoint analysis, and there are 3-4 things. The first thing that I will talk about is something called a pricing decision. So, how I can use this particular thing to decide a price of a product. So, one thing is simple here. So, let us say keeping everything same, if I change from capacity 6-seater to 4-seater, how much preference is dropped? The preference drop is minus 2.4 to minus 4.6, fair enough. So, minus 2.4 to minus 4.6 means how much? It is actually minus 2.2. So, if I change my capacity, from 4 to 6, from 6 to 4, the corresponding change, the delta utility is minus 2.2, fair enough. Now, how I will price that? How I can compensate that? By changing the price. So, price, if you see carefully, the prices decision is something like that, from, let us say it was in 8 lakhs. Now, I have to decide the price. So, in 8 lakhs it is 2.6 and 4 lakhs it is 3.4. So, if I just draw this at 8 lakhs and 4 lakhs, this is price, this is utility or something like that. So, the corresponding preferences is at 8 lakh it is 2.6, let us say this is 2.6 and this is 3.4. Okay. And I have to, so what is the distance between them? The distance between them is probably 0.8, right, 0.8. So, I cannot actually, I have to further extrapolate it. So, if it is 8 lakhs, I have to further extrapolate it because I have to find out minus 0.2. So, it is an assumption then that below 4 lakhs also it will go in the same level. So, for 4 lakh drop, the utility that you get is 0.8. So, how much do you have to drop? It is actually it will come to the negative part. So, this is probably not a good example, but I would try to say, let us say your price was 12 lakh initially. So, I will just change it quickly. So, let us say your price was 12 lakhs initially. So, at 12 lakhs you were at 0, fair enough. Now, you have to manage for minus 2.2. So, from 0 to 2.6 drop happens. So, when you change from 12 lakhs to 8 lakhs, the utility drop happens from 0 to, so you gain utility 2.6, but you have to gain 2.2 because 2.2 is something that you are losing. So, how much will be that thing? So, if this is at 8 lakhs it is 2.6 and at 12 lakhs it is 0. So, this is the table, this is the equation, and you are trying to find out where this 2.2 comes. So, let us say this is 2.2, correspondingly this is the point, and if you write a straight line, you try to find out what is this score, right? What is this score? So, how will I find out that? Let us say this distance is x. How much is this distance? This distance is 2.2. So, can you check carefully check. Can I write x by 2.2 is equal to 4 by 2.6. So, this much I would say this much divided by this much. So, for the small triangle, the ratio between the x and the height, which is 2.2, is equal to, for the bigger triangle, this much by this much, which is like 4 by 2.6. So, then what is x? X is 4 by 2.6 into 2.2, whatever is the value, and what is your optimal price that you can do? Your price is basically 12 minus x, whatever is the value. So, you can get a little bit of pricing by this. That is one way. Another way, I just told you that it might not have been a good decision to include price here. So, let us say instead of price you have taken something else, you have taken fuel capacity and let us say I do not know the engine type, or let us say whether there is some so power steering is there or not, or something like that, I do not know, some other variable you have taken which is not related to fuel, not related to capacity. But instead of asking rating or ranking, in the data set you have asked willingness to pay. If you remember, what is the price, what is the best price that we can do? We can find out the optimal willingness to pay of the customers. If so, customers will try to maximize V minus P. We are trying to find out this V. Instead of that, we will find out the price component. We will say that WTP, willingness to pay, is equal to my price. So, if I find out willingness to pay of the customer, then it will actually give me directly how much they are monetarily, rather than preference and etc., how much they are willing to pay for a certain attribute, an attribute level. So, I directly ask willingness to pay and they give me the monetary figure, and then I do the same regression. Now, I get this particular equation as a function of, so all of these things is willingness to pay. If I have a new observation, let us say a new car, and that car has diesel with capacity 6 and with price 2.6. So, I can directly price 8 lakhs. So, then I can directly find out what is the willingness, or in not price, probably something else, I do not know. So, category variable x3, which is 8, I think, let us say. So, then I can directly find out what is his willingness to pay. His willingness to pay will be, the coefficient is 10. So, 10, if it is diesel then it is 0, 10 plus 0. If it is 8 seater then again plus 0. So, again plus 0, and then if it is something else plus 2.6. So, 12.6. So, something like that. So, instead of asking the preference, I can directly ask the willingness to pay, and I can find out the price that they are willing to pay. That is one way. Another way is, if you have by chance have taken price as one of the consideration, you can do this kind of a maths a little bit to find out, it is a interpolation or extrapolation. By chance, if you are trying to find out that if your price is 12 and if you have to want to find out how much will be the price above 12, then you have to do extrapolation with an assumption that this point can be extrapolated this way and this line can be extrapolated in this way. So, that is an assumption that you take, but you do extrapolation and find out that what is the optimal price. In this case, from 8 to 4 drop I could not do, because then the price would have been negative, which is not a practical case. So, that is where we will stop this particular video. I will come back with the next video with further more applications of conjoint analysis. Thank you.